So with the filters being a little bit larger in this screen, I've noticed a few more things shifting around as we go through the selection set. So filters, if you don't have that bar showing up, it will be an F5, turns it on, turns it off. F6 toggles a filter on and off. So right now, if I were to select all filters, and then F6 toggles them all off, and we'll see that little funnel come up to where only the items that are selected. So if I only wanted to select for edges, and this is where the filters will kind of catch up to you. If you hit E for some reason, or you hit, where's the surfaces? Faces. If you hit X, like a Control X for a cut, and you miss the control and hit X, it could turn your filter on, and if you're not seeing it, you get the little funnel, and then you can only select faces. You can't, it's not supposed to select edges. Well, it highlighted the edge, doesn't mean I'm going to be able to select it. So F6 will toggle the filters off and on, and F5 will show the filter bar and show and hide the filter bar. So this is going to put us into our assembly, and we'll just use the default assembly. And again, do I want to be in metric? All right, so my C bracket was the first item. We're just kind of floating out in space. If I place it, I don't really know where the origin is, but if I come back to the check mark, it highlights OK, and that's going to put me origin to origin. What I've been watching a little closer is that that rotation, and I don't know if it's just habit that I try to create the parts in the orientation that I see them coming into the assembly, but that adjusts. So what happened to my M10? So there's no hole coming through the back, but I'm pretty sure I put that in there. So if I come back to the C bracket, well, I may have hit a Control Z in there somewhere. So let's go ahead and see if there's a redo. Can't redo. All right. So let's just put that back in real quick. Not sure what happened, but it's not there. Or I hit a Control Z for something else and it went back further than I expected it to. All right. So this time I pre-selected. I don't have the 3D sketch. Select midpoint and the point for the location, make those horizontal. The origin or the midpoint, make that vertical, and accept. Control 7 puts me back in isometric, and Control S saves the part. So when I come back over to the assembly, because of the associativity, I let it update, I'm going to see that geometry now. Okay, so that makes me a little happier. We're going to insert the components. Since these are open, I'm going to see the items. If I don't have the item I'm looking for open, then we'll just browse for it and pick it up. All right, so the let's go ahead and bring in one of the like the pivot screw. All right, so this comes in, and we don't see the configuration. Oh, there it is, default. And then if I come over to the pivot screw, that will update. And I don't have any automatic mate relations applied to this part. So that'll be one of the things we want to look at in this video, is how we can speed up this process if I'm going to be creating a lot of these. All right, so I'm just going to place it, and then select the face, Control select the face, and hit concentric. Now, I don't really care to lock rotation. This is in 2020. If you're in 2019, the lock rotation and the flip mate alignment little pop-ups came in with 2020. And then I'm going to scroll, zoom in to be able to see that face. Anything that you're trying to select way out, that's going to be kind of difficult. So use the scroll wheel mouse and rotate in. I'm going to hold down the control button, and we're going to go right to coincident. All right, and that puts it into place. And so everything kind of lines up, looks good. Well, that's going to be some interesting check on the interference. All right, so I do kind of want to see the screw be able to rotate, and probably for an advanced video we'll make this turning out. But since this is just pretty much going to come into contact and stay in place, we could have locked the rotation. All right, so inserting the component. Let's go ahead and bring in, say we can do the insert components. That's probably my habit. That's why I go to it. If I pick the part, hold down the control and drag it in, I'm going to get the very same configuration of the part. So I want to change this configuration, and I'm not seeing, there it is. All right, so somewhere in there when I clicked, I didn't see this pop up. So on the right mouse, it took it a second, I guess. It had to think about it. All right, so we switch over to the adjustment screw. I have to hit the check mark for it to change. Now we have that geometry. All right, so to get this into position, select the face, control select the face. I'm pretty much going to go face to face, plane to plane, and then we'll go to concentric because of the geometry. Downside is it threw it a little ways out, but that's kind of the orientation. Pretty sure this is going to be in contact with that piece, so I don't know exactly where it's showing up. And then I don't see the cosmetic threads, which means that on my view, if we check real quick, don't see those turned on in the annotation. So we'll have to go identify that if we want to see the cosmetic threads. They can be kind of distracting at this level. All right, last one is the arm, and we can come over to the actually to the File Explorer and open in SolidWorks. I can grab the arm and drag it in. All right, with this I don't get that that rotation button, but that should be okay. And if I center this, we'll select the face, control select the face. I think I got the edge there. All right, so our options are concentric, but I'd like to kind of see how this moves, so I'm going to try tangent on this one. All right, so tangency, and that is an outside tangency, which is a little strange. I don't know that tangent flips the mate alignment, but let's go ahead and check. So that puts it on the inside, and that kind of shows me how much this is able to move. And I know it can move up and down in that process. So let's go ahead and center it. If it's all the way down, that screw is just barely going to contact it, but it's going to be enough to lock it in place. So maybe we need that adjustment, and then the locking screw is going to push it back towards that and hold it into position. Alright, so to locate it, I'm going to use one of the advanced mates, so we'll go directly into the paperclip. I want to pick the advanced mate and use the width. So width says that it's going to be centered, and that was not the one that I wanted. We have basically a tab and a location, so we're going to pick two faces off of one part, and then it jumps down to highlight in blue, rotate over, select two faces off the other part, and that will hold it in the center. So we're still able to kind of see how this moves at various locations and stays in the tangency as it goes through the process. All right, and then the last tangency I'm going to put on is between the end of the screw and that face, because it's an arc. And since I'm in the mate property manager, I don't have to hold down the control button, and that should be, oh, we need to go back to the standard mates. That's going to go to tangency. It didn't update, but it is moving. There we go. Just had to give it a chance to catch up. Alright, so as this moves around, it doesn't necessarily stay in contact as a tensioner, and it's able to move a little weird and also have some interference, some collision. Alright, so that gave me some over-defined conditions. It wasn't super happy with that. So let's rebuild one more time. Popped up, it went away. Not quite sure why it couldn't solve for those geometries, but we'll try the rebuild first, and then I'll hope for the best. All right, so I do want this to be somewhat static for the initial. So if I select the a face and a face and make those parallel, that just kind of puts it in a position where it's not going to have as much weird movement. The adjusting screw is able to rotate, and if it was set up to move in and out, we'd have a little bit more control over it. But I think that's pretty good. So we'll save the document, P6-10. And be ready to go on into the drawing.